wanted to go through one of my scripts. I think it's kind of useful. It's a Python script for QA testing backend endpoints in a web application. Suppose it could be kind of modified for different types of applications. But in this case, I'm looking at a web application that I regularly test, and I have a series of endpoints that I know about. Some of these might be hidden, some of these might be password protected, but I need to run through them and make sure that that no type of attack, whether it's XSS, SQL injection, etc., would trigger some backend problem, either a vulnerability or that it wouldn't actually cause like denial of service. So I came up with a little utility, and the utility is written in Python, and I make use of the requests module. Most of my endpoints in the applications that I test are behind an authentication system, like you have to log in first before you can update profile data, for example. So to do that, I also pull in this HTTP basic auth class from the requests auth. I'm storing data for each payload that's going into each security test in an external file called data. And my particular script is multi-threaded, but that's optional. So you can see I'm bringing in the thread, multi-threading from thread. And then sys, I just use sys only for one call to give an exit code. That's it. So the script runs like this. It's pretty much basically a little menu-driven script. And the idea behind it is that you have an application in a test environment. And I put out this little menu option, and I say, you know, for option 1, we're going to do data validation, which is going to be XSS, SQL injection, URL encoded and mixed encoding attacks. And then option 2 is going to be to fuzz endpoints, which is going to be like a typical buffer overflow fuzzer. So I'll step through it real quick, and then obviously this won't run because I don't have real data in here, but I'm going to also link to this in the description so you can see the code on GitHub and modify it for your own testing. Now, of course, I have to say this is for use only with endpoints you have permission to test and to test security on. One more thing to say is, regardless if you get a successful exploit or vulnerability in the application you're testing, there could be a byproduct of a denial of service. I've seen this happen where some developer did not anticipate a mixed encoding string coming into an endpoint, and when it comes in, it explodes and creates gigs of data in the log files, which cause the server to crash. So you'll want to monitor your server logs when you run something like this. Anyway, here's what I do. I'm going to zoom in here if I can. So first thing I do is I present this little menu, and then I ask for the raw input at this prompt. And if a user says, okay, I want to do option 1, which is I want to hit these endpoints with XSS and SQL injection and mixed encoding attacks, then I happen to know that I need to log the user into a test account. So I prompt them with, what's your username, what's your password. Then I come down here and I basically ignore the timer. That's just for testing. I basically say, okay, for target in my endpoint list, which is going to iterate over a dictionary of supplied endpoints, I'm going to attack this target, and basically you're going to see that what I do is call this, I'm basically passing this to a thread, but the method I'm doing I call bad data injection. Not very creative, but that's what I call it. And what I'm passing into that method is the arguments, the username that you supply, the password that is supplied, something called bad blood, and that happens to be a list, and then the target, which is an element from the list, and then the endpoint list target. So this is basically taking the dictionary and I'm supplying a key, the target, to pull out the value. And what that probably sounds kind of confusing. It's this thing at the top. First of all, what's bad blood? Bad blood is a list of all these different SQL injection and cross-site scripting attacks that I found from OWASP.org on their XSS filter evasion cheat sheet. So you can check that out. It's a lot of ideas on how to test the filters that are probably in place on web applications that you test. So you can try passing these in, and this value, bad blood, will pass in each of these attack types into each endpoint to try and violate it. The endpoint list, let me zoom out a bit, is this. It's a dictionary. The key is a URL, and the value is a bunch of JSON data. What that JSON data is, it's going to look like this. It's in another file. Just to keep things clean, I put it in another file. And I basically pass in, like, let's say you had a JSON payload of ID, description, and next action, whatever. And let's say the description is the only field that a user could type in a value. Maybe it's your profile description. So I use the value evil. And currently evil is set to no value. But when evil is passed in, when this is passed into the actual injection method, I basically take it and I replace each of the values of that value evil. I replace it with one of these guys from bad data. So something like, kind of confusing reading this way, but something like, obviously you see this is a big block of an attack. So something like that thing right there, would get passed into the description. And then after it's submitted and posted, I would pass in the next one, which is this guy. And on it would go, and it would keep doing like all these iterations over the endpoints, trying to make all of these, try to violate the endpoint in some way. So the endpoint dictionary, the endpoint list dictionary, has as its key the URL. So imagine this is an endpoint to update maybe your profile picture, and then, or your profile title, and then maybe this is maybe personal information. And so these are maybe different endpoints. So I'm just giving examples here, and maybe this one takes an email address. So we're going to pass in all those different values in that list of evil XSS codes, and we're going to pass them into each of these fields and iterate over them. So basically, we're iterating over a list of endpoints in a web application, and that in turn is iterating over this list of bad injection attempts. Now, another key here is, since I'm logging in and to hit these endpoints, I needed to capture the session cookie of the login. And that's why I'm using requests instead of mechanize. I had very horrible luck with mechanize, so I ended up using requests, which let me capture the session information really well. This is the login method, so basically you would replace it with your own login endpoint. And let's say the login endpoint takes a username and password, and then I'm basically passing that in using the HTTP basic auth. But once I'm logged in, I have a session cookie. So once I have that session cookie, I can now hit these endpoints. As you can see, I'm using this here. And that's pretty much it. So it will iterate over, let's say I had 10 endpoints, and then each endpoint maybe has 2 or 3 points of data that is user submitted that I want to try to violate. Then it will go through all these different cases. You can see some SQL injection in here, some null bytes getting passed in. There's a lot of different, scripts that I'm trying to run. So it's just basically different attacks that are going to iterate over each endpoint. Now the fuzzer is a little different. If a user is at the menu and they choose to fuzz the endpoints, I thought it might be useful to see if there were any endpoints that were setting like an arbitrary value of how much characters it's allowed to take into a buffer. And then I'm trying to push beyond that. And so this is like a typical buffer overflow fuzzer. And it works like this. You take in very similar attributes: the username, the password, the endpoint, the data, a character called the buffer char, and then the size of the buffer, which I default to 50. What I do, I first log in to get the session cookie, and then once I have the session cookie, I create this list or array of buffer characters. And I have this, so let's say the character that you're passing in is the letter A as your buffer character. Okay, so buffer character is A, and then I'm setting the counter to 100. And then I say, well, the length of the buffer is less than or equal to the size. Go ahead and do this. Append the buffer multiplied by the counter. So if the counter is 100, and I got a buffer of 1, we'll create 100 instances of the letter A. So you'd have 100 A's. Then we're going to up it, and we're going to repeat this process until our size is met. And once our size is met, then we'll have this big list out here, or array, if you prefer the term, and it would be like something like on to 100, and then to the next increment, and you would have these huge strings that would be passed into here. So what I'm doing, I'm reusing the bad data injection method, but instead of passing in this list of XSS attempts and encoded values, instead of using that list, I'm using this new list of the buffer sizes. So you'd have 100 A's, 200 A's, 300 A's, 5,000 A's, and would pass these in until it would break. Now, what I've noticed is that sometimes you'll see stack overflows on the back end, or you might see some other errors on the back end logs. So it's kind of useful to see what would happen, because sometimes the front end can be coded to say, yeah, I only take 160 characters for a person's self-description. But then what happens if you pass in on the back end to the endpoint, straight to the endpoint, something like 5,000 characters? Does the back end also handle that gracefully? So these are the two tests currently, but you could obviously add to this kind of script different types of tests. You could break it down the different, SQL injection versus XSS versus fuzzer, whatever you wanted. Load. And that basically is it. So you would have to know several things. You would have to know your endpoints, and you would also have to know the data that's used to fill the endpoints. So you would have to know, if it's a REST endpoint that takes JSON, you'd have to know the payload. And you can get that obviously through the console of Firefox or Chrome, or you could use Firebug, whatever you use, and then you capture the example payloads. And then you would basically, for the bad data injection, you're just basically going to loop over the bad data, and you're going to supply each element in the list. In this case, here I have an example right here with the value from bad data. And then, and of course you're looping over this huge list of endpoints. So for each target, each endpoint in the endpoint list, you're basically going to send that to, this bad data injection method. I've had good luck with this. I've had various applications that I test that have shown vulnerabilities that basically the XSS plugins had, or XSS utilities had to be modified to take in different attack vectors and sanitize them. Anyway, I hope you find it useful. That's it.